I'm going to start explaining first the legal framework in Europe for occupational health and safety, and then I will move to more specific aspects on how to carry out the exposure assessment. So the legal framework is based on the Treaty of Functioning of the European Union, mostly on Article 153, but Article 114 is also very important. This Article 114 gives the European Union the authority to harmonize national law, to remove trade barriers in the internal market, and to achieve a high level of protection for consumers and the environment. So on this basis, many directives have been approved. Very relevant for today are the General Product and Safety Directive and the Restriction of Hazardous Substances in Electronic Equipment Directive. And these are important because they introduce restrictions on substances in the products. And this aligns with the first principle in the hierarchy of risk control measures, which is elimination. And the Machinery Directive also establishes that machines should be designed to prevent emissions of toxic substances, addressing the principle of safety by design, which is very important in OSHA. But the article that allows the European Union to legislate specifically to protect workers' health is 153. And on the basis of this article, it was approved what the so-called Framework Directive that lays down the main principles in health and safety and establishes the obligations of employers and workers. And then there are many directives on specific risk. Very relevant for today, all those related to the chemical risks, the Chemical Directive, the Directive on Carcinogenic, Mutagenic, and Reprotoxic Substances, the Asbestos Directive, and the Directive on Indicative Limit Values. I'm not going to be dealing with biological risks, but they are also present in the recycling of waste, as many other risks, like physical risk and also all those related to the workplace safety, including the use of personal protective equipment. Then there are also directives that specifically address vulnerable workers, like young workers, those under 18 years old, and also workers that are pregnant, have recently given birth, or are breastfeeding. But apart of those, there are also a couple of pieces of legislation that are relevant for today, which is the WE Directive that includes many regulations on the collection, the treatment, and the recovery of electrical waste. And soon we'll also introduce requirements on the traceability of the substances in these products. And then REACH. REACH addresses manufacturers and distributors of chemical substances. So if you manufacture or distribute a substance over a ton, then you have to register and supply a wide range of information on the hazardous properties of that substance. Based on that information, the substance can be allowed without restrictions to be used in any product, or can be subject to restrictions, or even can be prohibited. As I said, aligning again with the principle of elimination of the risk, or substitution by something that is less toxic, that is the main objective when it comes to protect workers' health and safety. But apart from the legislation, the European Union has other tools to help with the implementation of these directives. Like every 5 years, more or less, it publishes a framework, a strategic framework on occupational health and safety based on the current challenges. For example, the last one that was approved in 2021, it was focused on the risks derived from the working with digital platforms, and also the risks derived from the green and demographic transitions. Apart from that, there are also guidelines, specific guidelines for the directive. This is just a list with the categories of guidances from our website in OSHA, where you can have a closer look. And then there are also standardization bodies. The standardization bodies are quite important because, as you may know, the use of standards demonstrates conformity to the safety objectives of many directives. Specifically in SEN, there is like an advisory group on occupational health and safety, and then they discuss what sort of standards are required to facilitate with the implementation of the legislation. And then apart from this, then we have the agencies and the committees. Agencies like EU-OSHA, that we have a whole range of tools to carry out the risk assessment. There is one specific tool on dangerous substances, although unfortunately it does not cover recycling processes. And then, as Annick mentioned, we also provide evidence. We just published last year a large study on exposure to occupational cancer risk factors. Then ECHA is a regulatory agency, is responsible for the REACH regulation that I just mentioned. And the webpage in ECHA has a lot of information on the hazard of all those substances that are registered. And that information is available to the public. There is even like a library, that's what you're seeing on the screen, where you can search a substance and you can get the REACH dossier and a summary of all the hazard information. And then there is another agency, Eurofound, that is mostly focused on the working conditions and the trends on the labor market. And then we have the committees, like the most relevant ones are the Advisory Committee for Health and Safety. This is a tripartite body representing the member states, the unions, and the employers. And within this committee, there are many working parties. One of them is the Working Party on Chemicals, and it works very closely with the Committee for Risk Assessment that sits under the ECHA, for example, for the establishment of occupational limit values that are very important to protect workers' health. And then is the SLIC committee, the Senior Labour Inspectors Committee, that assists the Commission with the enforcement of the legislation. Okay, so I'm going to move now more to the technical aspects on the risk assessment. I'm going to focus only on the risk assessment of chemicals. What you see here is the classical image to illustrate how the risk is estimated in this context, which is like a combination of the hazard and the exposure. What happens in the waste recycling is that we don't see the lion. Like most of the emissions that come from the different products are unknown. And therefore, it's not possible or it's more complex to have an estimation of the risk a priori. Most of the substances that are released is what we call process-generated substances. So they don't have to comply with REACH because REACH is only for substances that are manufactured and not the product of a process. Although the REACH legislation, it does say that an estimation of the exposure shall take into account the transformation and the degradation of the product. They don't have to comply with the CLP regulation, so there are no safety data sheets that can inform us about the hazard properties of those products that are being recycled. And as Leah mentioned earlier, what we have in most cases is like a mixture of chemical substances that depends on the different waste stream and also the process. Collecting, sorting, the shredding, milling, crushing, or the specific process for the recycling. And all these emissions, although they're not covered under REACH, as I said, or CLP, they are covered in the Chemical Agents Directive that defines a chemical agent as a compound or a mix that occurs in the natural state or produced or is used or is released, including waste, and is produced or not intentionally and is or not in the market. So the main challenge during the recycling of waste is to, as I said, to identify the hazard. Now, thanks to many studies that have been done, we know what we can find in the different waste streams. So during the recycling of electronic waste, it's very frequent that the dust includes really toxic metals, like, for example, lead, cadmium, and nickel, flame retardants, or even PCBs that, although have been banned, is not unusual to still find them in many products. But Tina's going to talk after me about a case study on the electronic waste and also on the plastic waste. On the plastic, like the dust is going to be, the dust is going to contain microplastics or nanoplastics, flame retardants too, but also we're going to have volatile organic compounds and also inorganic vapors. During the melting of the polymers to recycle also it's very likely that polymer fumes are formed. Then in the textile waste, again, the dust will be formed by microplastics or nanoplastics, and we can have also all the additives that are added to the textile. And then in the fabric waste, again, we find volatile organic compounds, like, for example, formaldehyde, and also inorganic vapors that are used, for example, to bleach the recycled paper. And I'm not mentioning other waste streams that maybe are a little bit more controlled, like, for example, is the industrial waste, automotive waste, and glass waste. And as I said, this is only the chemical risks, but it's also well known that there are also many bioaerosols during these processes, and workers can be exposed to fungi or endotoxin. So how can we start if we don't know what are the chemical substances that workers are exposed of? Well, checking the literature and seeing what you can find there, depending on the waste stream. Once you have a list of the possible substances, the next step is to classify them, taking into consideration what is the measurement method that you have to use to measure them, and also to prioritize them. Prioritization should be given to all of those classified as carcinogenic, mutagenic, or reprotoxic, or those having an occupational exposure limit. So once this list is elaborated, the logical classification is to see what type of particles, what is the relevant health fraction, whether it's in the respirable fraction or the inhalable fraction, what is the boiling point of the different box that you have to see what equipment you need, and also see what inorganic gases you may find. The measurement method for this is, it doesn't have to be quantitative. The aim here is to check whether the chemical is present or absent in the workplace. So you can use a qualitative method, like there are nowadays like many sensors that can let you know whether you have, for example, like formaldehyde or benzene in the air. And then the measurement strategy is also simple. It has to be with putting the instrument close to the emission source to make sure that you actually are capturing everything that is being emitted from that task. And obviously, you have to test this in all the different processes. Once you have confirmed what chemicals are present in the workplace, the logical thing is to review your risk management measures before you move to a regulatory workers' exposure assessment. Because the regulatory workers' exposure assessment, we're going to see it now, is expensive. And if you don't comply with regulation, it has to be redone. So it's logic that first you make sure your management measures are effective, and then you move to the chemical risk assessment to check compliance with the occupational exposure limits. For this, there is like an standard that is not compulsory unless national legislation says so. And obviously, it guides you through all the process. The information that you need is the hazard information that is in the form of the occupational exposure limit or the biological limit value, although there is only one at the moment for lead. And this information is in the national legislation. There are some occupational exposure limits in the Chemical Agents Directive and the Carcinogens, Mutagens, and Reprotoxic Directive. But as I said, these are directives of minimum requirements, and the member states can introduce more stringent regulations. So they might have lower occupational exposure limits than those in these directives, or have other substances with limits that are not listed in this directive. So it's very important here to check the national legislation. And then you have to estimate the time weight average exposure concentration on the worker. This is what we call a personal exposure. And it's usually what you sample here is the air in the around the mouth area of the worker. Usually you put a sampler on the label of the worker. And I'm saying air because most of the occupational exposure limits and most of the exposure is by inhalation. But it's important to check all the exposure routes because thermal exposure is also quite important. And then it's very important to see the characteristics of your workers. If there are many workers, it's not necessary maybe to sample all of them. You can create similar exposure groups based on the characteristics of the process. But then it's very important to see whether you have young workers, and if the workers have disclosed this information, whether you have pregnant workers or workers that have given birth or are breastfeeding, because the occupational exposure limits may be different from those, or in some cases, they cannot be exposed to certain substances. So once you have this information on the exposure of the worker and the occupational exposure limit, you estimate what is called the exposure index. And well, it's not as simple as this. There are some statistical rules that you need to comply with to see whether actually you are, let's say, below this occupational exposure limit. It's true that there are many substances that do not have an occupational exposure limit. In these cases, one could use the data that is provided in the REACH dossiers. This is the derived non-effect level, and using the same exposure information. This is what is called the risk characterization ratio. This is not in OSHA legislation. This is done in REACH, but for those cases where there is no occupational exposure limit, it does give you an estimate on the risk. And once you have characterized your risk, then you move to the next step on the risk assessment, which is risk management, giving a priority to the prevention through design and applying, obviously, the hierarchy of controls where, as I said, elimination and substitution are the most important. And then, obviously, very important to make sure that you comply with the occupational exposure limit and the biological limit values. And legislation indicates that it's not only compliance doesn't consist only on being below these limits, but the exposure, it should be lower to the minimum reasonably practical value. Many substances then with occupational exposure limits are subject to health surveillance requirements, and also there are special requirements for vulnerable workers. Workers have to be informed of the risk and trained so they can carry out the work in a safely manner. And they have to be consulted also on the risk management measures. The risk, all the risk management has to be reviewed and updated. And again, the consultation with the workers is also a legislative requirement. So to summarize, the most important thing and the most challenging when it comes to waste recycling is to identify the chemical substances. Once these have been identified, then you have to move to estimate what is the worker exposure, paying attention to those that are vulnerable, and then implement a program to reduce or control exposure, always applying prevention through design and trying to achieve the lowest exposure as reasonably practicable. And then this translates that for each process in the different waste streams, possibly there are different options for recycling, and then obviously you have to pick up the one that is going to result in lower exposures. It's very important to consult with workers and always check the effectiveness of risk management measures. But what is very important too, and this falls a little bit outside OSH, but is very relevant for OSH, is that the design of products in a way that facilitates the recycling, so the process is safer for workers and does not recirculate substances of concern.